All right, today in this video, we're going to talk about piecewise functions, and we'll talk about domain and range when we meet together in class next time. All right, so let's talk about an experience that we have all had online shopping where they offer you free shipping once you spent enough money, right? So they might say that shipping is $8 or free once you spend $50. Okay, so when it's time for you to check out, you go look at your cart and the computer calculates your total two different ways. And for the purposes of this example, I'm going to ignore sales tax. So let's say that you've spent X dollars on your merchandise. The computer is going to charge you X dollars of merchandise plus your $8 of shipping, but they're only going to do that if what you've spent is less than $50. So they're going to use that formula if X is less than 50. But if you've spent more than $50, they're just going to put X in there. You just get to pay for whatever you spent. So that's if X is bigger than or equal to 50. So in math, when you have a formula or a function that has more than one piece to it, depending upon the value that you're plugging in, we write it this way with a bracket because we're recognizing that those are two parts really of the same formula. So we would say f of x. Okay, so we're going to get used to plugging into these kinds of functions, and then we'll graph a couple of them. All right, so let's look at this big beast of a piecewise function. This one has three pieces to it. This says if you're going to plug in a number less than -2, then you're going to use the formula x squared. If you're going to plug in a number between -2 and 3, you'll use the formula x plus 3. But if x is bigger than 3, then your answer is just 5. Okay, so we'll just evaluate a few of these. So f of 0, we want to plug into the function. We want to figure out which of those three formulas is valid for x equals 0. So x equals 0 falls in between -2 and +3. So we're going to use x plus 3. So x plus 3, I'm going to do 0 plus 3, and I get 3. All right, let's just keep going. F of 3, let's see, 3 also follows the same rule as 0, because that's where the or equal to 3 part comes. Right on the bottom it says x greater than 3 not equal to. So 3 is going to get the same formula, x plus 3, 3 plus 3, which is 6. All right, f of 7, now x is 7. 7 is a number bigger than 3, so 7 follows this rule here. So there's really nothing to plug into. There's no x in that formula. That third line of the function just says if x is bigger than 3, the answer is 5. Okay, so 5. -5, finally we get to use the top formula, right? -5 on the number line. Okay, less than -2 means to the left of. So -5 is less than -2. So we plug into the formula x squared. So x squared, plug in -5, and we get 25. And then f of pi, there's always room for pi. F of pi is 3.14, right? So 3.14 actually follows the same rule as 7 does, right? That's bigger than 3, pi. So that rule, the answer is always 5. Right, so there's a little bit about evaluating piecewise functions. Piecewise functions are functions. They're always going to give you one and only one output. So you're never going to plug a value into all three formulas. You're only going to plug into one of the formulas in the function. All right, so here's our first piecewise function that we want to try and graph. And it's made up of two equations that we already know how to graph. These are just lines. We just learned how to graph lines. So I'm going to graph these two lines in different colors, and then we'll come back and worry about the if part of the function. Okay, so I'm going to pretend that y equals 1/2 x plus 3 is the only function that I'm graphing right now. So that is a function that has a y-intercept at 3. So we'll start off there. And then we want a slope of 1/2. So I'm going to go up 1 and to the right 2. So up 1 and to the right 2. Up 1 and to the right 2. All right, and you could plot a couple points to the left if you want as well. Down 1 and to the left 2. Okay. And then I'm just going to fill in that line. All right, and we're gonna have to mess with that line in a minute, but let's go ahead and graph 5 minus x. So I'm gonna graph y equals 5 minus x. And this one might be easier for you to think of as negative x plus 5. So we can think of that slope as being -1 and the y-intercept is 5. So let's graph this one as well. So y-intercept of 5, and then slope is -1. So down 1 and to the right 1. Down 1 to the right 1. And I'm plotting a lot more points than I need, but okay, so we're gonna need both of those lines, but we're not gonna need all of both of those lines because the function says, wow, I really like that red line that you drew me, but I really only want that line if x is less than 2. Okay, so let's think about what x less than 2 means. Okay, well, 2 is over here on the right side. Less than 2 would mean this direction. I put a circle there underneath the 2 because it says less than, not less than, or equal to. So this is x less than 2. Likewise, it says, I like that green line, but only if x is greater than or equal to 2. If x is greater than or equal to 2. All right, so I'm gonna take my final answer pen in black, and I'm gonna go up and keep the parts of the line that the function is telling me. Okay, so for x less than 2 on the red line, I'm gonna go up to this point. It's at 2, 4. And so I'm gonna kind of copy that open circle there and just keep that part of the red line that's on the red half of the paper. All right, and that's gonna be my final answer. And then I'm gonna come in with my eraser and I'm gonna get rid of the rest of that red line. Okay, now I'm gonna go do the same thing for the green line. The green line has that closed-in circle because x greater than or equal to 2. I'm gonna take my final answer pen and go up to the green line at x equals 2. This is 2, 3. And I'm going to fill in that dot and then just keep the green half of the paper below. And then I'll come and erase the rest of that green line as best as I can. All right, and that's my piecewise function. And if I look at that, it passes the vertical line test, and it kind of looks like a function, like a Frankenstein function that took two parts of two different graphs and kind of taped them together, all part of the same function. Okay, here's our next piecewise function. We've got 2x minus 1, 3, and -1/2 x. So we're going to graph all three of these lines like they're not in a piecewise function, and then we'll kind of chop them up. Okay, so I'm going to start off with the first one, y equals 2x minus 1. That's a line with a y-intercept of -1. So I'm going to come down to -1. And then the slope is 2, 2 over 1. I'm going to go up 2 and to the right 1. So up 2 and to the right 1. Up 2 and to the right 1. And let's fill that in. All right, so our next line is 3. Okay, that's just y equals 3, f of x equals 3. And I recognize that equation as the graph of a horizontal line just at y equals 3. And then the last line is y equals -1/2 x. You can think of that as -1/2 x plus 0. It's got its y-intercept at the origin. And -1/2 x, this means we're going to go down 1 and to the right 2. So down 1 and to the right 2, down 1 and to the right 2. Right, and then we'll go fill in that line. All right, so now let's chop those up. Okay, so I graphed 2x minus 1 in red. So for the red graph, I want x less than or equal to 1. Again, kind of set up a shaded number line down below. Less than or equal to 1 would mean filled in at 1 and to the left of 1. So that's the part of the red graph that I'm going to keep. Y equals 3, I graphed in blue. This one's got kind of a sandwich inequality. That's got x between 1 and 4, but not equal to either one. So between 1 and 4, but not equal to either one. So open circles at the end. And then x greater than 4, so another open circle at 4, but greater than this time, so we're headed to the right. Okay, so again, you're going to think about kind of making these vertical cuts at the dots and holes part of those restrictions at the bottom, and then fill in with your final answer pen. So the red graph, I'm going to be at 1, go up to the graph, and I use a fill-in dot there because it says x less than or equal to 1 for that line. And I'm going to color in the direction of the red line on my paper. And then my high-tech eraser here, I'm going to come in and get rid of the rest of that red line that I drew. All right, final answer pen, onto the blue line. In between 1 and 4 with open circles, so x equals 1 on the blue line, x equals 4 on the blue line, and keep everything in between. And then go back and erase everything that's left over in blue. All right, last is my green line. I'm gonna go with my final answer pen at 4, go up to the graph. It's at 4, -2 for the green line. I'm gonna put a big circle there and shade in the green direction. So to the right. And then erase everything else that's still in green, which I can almost do. Some of it's still left, use your imagination. So your piecewise functions can have as many pieces as they come with, and you just graph each piece and then chop off the parts that you don't want and leave the parts that you do.